Okay, so just about in the home straight, boys. So what we're looking at now is our general solution for trig equations. And what that is, that's just another way of generating the same output that our calculator gives us if we don't restrict our domain. So you can argue that we're at the moment finding the solutions for trig functions over a restricted domain, so between 0 and 2 pi or negative pi to pi or whatever it happens to be. Our general solution gives us the solutions to an equation over the maximal domain, so over R. Okay, so I guess if we're trying to remember what the general solutions are, if we think about where the cosine function is positive or negative, my solutions for cos, if we think about it, it's cos, is positive in the first and fourth quadrants. So my solutions are 0 plus the angle, 0 minus the angle, or we go around to 2 pi plus the angle, 2 pi minus, then around to 4 pi plus, 4 pi minus. So my general solution for cosine is, we can see it here, 2n pi, which gives me a way of getting pi, so 2 pi, 4 pi, 6 pi, plus cos inverse or minus cos inverse. That way we're just working up and working down. If we consider the tan function, tan is positive those two quadrants. So we think about our solutions. We start at 0. It's 0 plus, come around to pi plus, 2 pi plus, 3 pi plus, 4 pi plus, 5 pi plus, etc. So for my tan function, it's just any value of pi plus tan inverse of whatever angle we're looking for. The sine function is the one that's a little bit more involved. If we think about whereabouts sine is positive here and there. Yeah. So it is even pi, 0 pi plus, 0 plus the angle, pi minus the angle. 2 pi plus the angle, 3 pi minus the angle. 4 pi plus the angle, 5 pi minus the angle. So we can think of that one as even pi plus the angle, odd pi minus the angle. Now 2n plus 1 is just a way of ensuring we get an odd number, because if you multiply any number by 2, it's even, and then if you add 1, it must be odd. So the 2n plus 1 is just a way of making sure we have an odd number of pi's, and if we have an odd number of pi's, we subtract. If we have an even number of pi's, we add. So let's look. Those exact solutions, you've got to try to remember them. All right, they're not on any formula sheet. On a Tech Active, you'll have the opportunity to have them on your calculator, but let's look. So first things first, we've got a cos function. So let's write down the rule. So the rule is for cos, positive there and there. So the solution x will be equal to 2n pi plus or minus cos inverse of a half, okay, which is equal to 2n pi plus or minus. Now cos inverse of a half is what? Pi on 6 is pi on 3. So they're my general solutions. So what we try to do often is try to tidy it up. If I take pi is common, if I take the third out the front there, then I end up with, well, I get plus or minus 1 on this side. On this side, I end up with 6n. Yeah, 6n times pi is 6n pi on 3, which is 2n pi. So that's my general solution. All right. Think about the tan one. So let's get here. So we're going to have quick sketch to help us remember. Tan is positive here and here. So it's 0 plus pi plus 2 pi plus 3 pi plus. So it's just going to be pi plus tan inverse of whatever the angle happens to be. So tan inverse of A, say. So we want to solve tan 3x equal to 1 on root 3. So in this case, I'm going to have 3x is equal to pi plus tan inverse of 1 on root 3, which is equal to pi plus, well, tan inverse of 1 on root 3 is pi on 6. Oops. There should be an n pi there, shouldn't it? Because I've got multiple values of pi. So 3x is equal to, again, if I take pi on 6 out the front, I get plus 1, and I can make that a 6n there. So 3x is equal to that, therefore x is equal to pi on 18, 6n plus 1. For my sine graph, let's just work out sine x is equal to root 2 on 2. Now for the sine function, there's two rules. Rule number 1, so let's come over here, sine is positive in those quadrants, so don't forget it's 0 plus 2 pi plus 4 pi plus. So the angle x is equal to some 2n pi plus sine inverse of root 2 on 2, or I've got pi minus 3 pi minus 5 pi minus, or I get the odd value, which is 2k plus 1, I'll put an n there, 2n plus 1 pi minus sine inverse of root 2 on 2. So if we work on both separately, 2n pi plus, well, sine inverse of that is pi on 4. Again, I can take pi on 4 out the front. That gives me an 8n plus 1. If I expand this, it's easiest if I expand that bracket first, minus sine inverse of root 2 on 2, which is pi on 4. So I get 2n pi plus 3 pi on 4. If I take pi on 4 out the front, I get 8n plus 3. Okay, so x is equal to. So there's the general solutions for my angles, for my equations. So now, if we just see that example 23 really is just a continuation, find the first three positive solutions. So what are the first three positive solutions? Yeah, so now if we want to use these formulas to get some solutions, so let's just say, let's bring them down. So from A, x was equal to pi on 3, 6n plus 1. So I need the first three positive solutions. So if I just put n equal to 0, I get 1 inside the bracket, so I get pi on 3 as a solution. Pi on 3 as a solution. If n is equal to 1, I get pi on 3 times 6 times 1 plus 1, 7, which is 7 pi on 3. And then if I put n equal to 2, I get pi on 3 outside of 12 plus 1, which is 13 pi on 3. So there's my first three solutions for that one. For B, x was equal to pi on 18 times 6n plus 1. So if I again put n equal to 0, I get 0 plus 1, so I get pi on 18. If I put n equal to 1, I get pi on 18 times 6 plus 1, which is equal to 7 pi on 18. And then if I put n equal to 2, I get pi on 18 times 12 plus 1, which is 13 pi on 18. Yeah. For the last one there, 2 sine x equal to root 2. I've got two possible solutions here. So solution 1 and solution 2. So if I put n equal to 0, from solution 1, I'm going to get pi on 4. From solution 2, I get 3 pi on 4. Then if I put n equal to 1, from solution 1, I get a plus 1, which is 9, so I get 9 pi on 4. N equal to 1 on solution 2, I get 11 pi on 4. So clearly from there, my first three positive solutions, I stop there at 9 pi on 4. The nice thing about, I guess, these general solutions are if I need negative numbers, negative solutions, so for example, if n was equal to negative 1 in B, negative 6 plus 1 is negative 5. Negative 5 pi on 18 would be one of my negative solutions. So if we've got our general solutions, it really is just a case of substituting in for some specific values to get the solutions within the domain that you want. So it really is worth contemplating, learning the general solution and using it every time as a process if you want. Okay.